Good day, learners. Today I'm going to take you through the solutions of Euclidean geometry that was written on the 15th of October. Without wasting time, let me share the screen. As I said, the test number 8 was about Euclidean geometry. It covered the grade 11 geometry and similarities of and proportionality of grade 12. Now, let's look at the first question. Learners, you should always make sure that you read the statement, because it's not always the case that the information will all be on the diagram. So read the statement to check whether everything's on the diagram. Remember the diagram sheet, you don't submit it at the end. Play with it. If you, after reading the statement, mark whatever you have read, you mark it on the diagram so that when you start answering questions, you know, like for instance here, you see that OM is 15 units. You go to OM, write this 15 units. MC is 3 units. You go to MC, write this 3 units. So that when you start working, all the magnitudes are marked on this diagram. Now let's look at the first question. OM is to the circle passing through BM and O. Is it a chord? Is it a radius? Is it a tangent? Is it a diameter? Now, first we'll say, which converses are you going to use? Now let's start. We are talking about the circle passing through B, M, and O. Now, if you see, BD is the tangent to the small circle, but it is a chord to the larger circle. So, and we know that a radius is perpendicular to a tangent. It means OC is perpendicular to MD. So for that reason, this angle here would be 90 degrees. If it's 90 degrees, then it means that OM, I wanted to say not OM, we are supposed to be OM. Let me just quickly show it. We talk about OB, not OM. Let's say we'll say OB. What's supposed to be OB? OB is the diameter to the circle passing through BM and O. The reason being that if this angle is 90 degrees, it means we are going to apply the converse of angle on semicircle. Remember, if an angle on the circle subtended by a chord is 90 degrees, then that chord is a diameter. It means in these two circles, BO is not a diameter, but it's the diameter to the circle passing through BM and O. Now, the second question, the sub-question of this will say, what is the length of MD? Let's check where MD is. What is the length of MD? Now, since AC is a diameter, it means angle ADC is 90 degrees. Your reason, you know that you will say the angle on a semicircle. We are referring to the larger circle. So angle ADC is 90 degrees, and this angle here is also 90 degrees. You know this grade 12 theorem which says a perpendicular line drawn from the vertex of a right angle triangle to the hypotenuse, divide the triangle into two triangles which are similar to each other and also similar to the original triangle. It means if they are similar like this, but when you shorten it, you will just say perpendicular from right angle vertex to the hypotenuse. Now, then you will say MD squared equals to MC plus times M times AM. But remember, since we know that OB on the statement that OB is 15, MC is 3. If OB is 15, MC is 3, it means OM. Remember, OC equals to OB. Read that. OB equals to OC. So now, if OB is 15, OC must also be 15. So it means if MC is 3, then it means OM is 12 units. So, and also OA is the radius, it will also be 15. Then it means AM is 15 plus 9 is 15 plus 12, which is 27. So that is why we'll say 27. But if you don't want to use that theorem because it's not commonly used, you can just first show that the two triangles are similar. They are similar. How do you do that? First, you'll say, let's talk about triangle AMD and triangle MDC. We know that here is 90 degrees, here is 90 degrees. So it means the AMD equals to CMD, they both equal to 90 degrees. And again, you come and say angle C equals to angle. Remember, if this angle, the whole of this angle is 90 degrees. Now, in this case, you'll find that C equals to angle A. So if that is the case, you'll prove that the two triangles are similar. If they are similar, you know that if two triangles are similar, the corresponding sides are proportional. When you write that in that order, you'll find that MD squared equals to AM squared plus MC squared. Then you'll just make MD the subject of the formula. Then you'll find that MD is equals to 9 units. Now the next question, calculate the length of BM. Let's check where BM is. BM is here. Now we calculated MD as 9 units. And then we also said in the first question that this line, remember BD, is a tangent to the small circle. And if it's a tangent, then this angle is 90 degrees. And the very MD is the chord to the larger circle. And we know that a line drawn from the center of a circle, or a perpendicular line drawn from the center of a circle to the chord, it bisects the chord. So then we say BM equals to MD, they both equals to 9 units. So your reason, you say perpendicular from center to chord. (1.4) Find the length of AB. Let's go and check where AB is. So we say the length of AB. The length of AB, it will be easy to calculate because already we know that AM is 27 units, which is 12 plus 15, and then BM is 9. Then you apply theorem of Pythagoras to get AB. So you say AB squared is equals to AM squared plus BM squared, and as we did here. So we know that AB squared equals to 27 squared plus 9 squared. Therefore, it means AM would be 9 root 10. Number 2, as I said, it's very important to read the statement and play with the diagram. Read the statement and play with the diagram. In the diagram below, O is the common center of the circles. O is the center. No, it's not the common. O is the center. O is the center of the circle. O is the center of the circle. Then OB is parallel to, or here it must be OB is parallel to CD. So OB is parallel to CD. OB is parallel to CD, and then BOC. Let me just take it down. So BOC BOC equals to 2x. BOC is equals to 2x, you see that. And then CDE is 7x plus 20. The value of x is, now if you look at this, there's no theorem which take us straight to the answer, because now this one is outside, but 2x is not the interior angle of this slightly quadrilateral. Where do we start? You say, okay, the angle that is related to this 2x is angle BDC. So we know that the angular center of a circle subtended by an arc is twice the angle on the circumference subtended by the same arc. So first we'll say, since these are on the straight line, we'll find this angle. Therefore, this angle will be 180 minus this angle, because sum of angles of a straight line is 180 degrees. So it means this angle will be 180 minus this one. Now that this is 180 minus 7, remember, if you say 180 minus into 7x plus 20, then it will be 160 minus 7x. Then this angle at the circumference is 160 minus 7x. So then you say 2x is equals to 2 into 160 minus 7x. Your reason is that the angle at the center of a circle is twice the angle on the circumference. You see, so the BDC is 160 minus 7x. Now, but now BOC equals to 2BDC, and angular center is twice the angle of the circumference. Then you say 2x is equals to 2 into the angle that we have calculated, which is at the circumference. Remember, as long as the two angles are subtended by the same arc, then one at the center will be twice the one on the circumference. Then 2 times 160 is 320, 2 times 7 is 14x. Then when you take 14 to the left, it will be 16x equals to 320 degrees. Then when you divide, then x will be 20 degrees. But as I said, you had to find this angle. There was no theorem which take us straight to the answer. We had to find the angle that can be related to this angle 2x by applying any theorem, whether it's Craig-Lemon or Craig-Twelve theorem. So the only thing is that this 2x is angle at the center, and then BDC is angle on the circumference. But this is a straight line. Then you first find this angle. You say this angle is 180 minus into 7x plus 20, because they're on a straight line. Then you'll find 160 minus 7x. Then this angle is 160 minus 7x. Then you say the angular center is twice the angle at the circumference. That is why the end will say, therefore 2x is equal to 2 into that angle on the circumference. And then we are talking about the 160 degrees minus 7x. You clear the brackets. And I take negative 14x to transpose it to the left. Then it will be 16x is equals to 320 degrees. Then x will be 20 degrees. Let's look into now the second question here. We didn't have the second question here. This one was supposed to be, I think it was cut by mistake. This one. Now you are calculating angle. You are required to calculate angle. Let's check. We are required to calculate angle COD. Now, we know that OD is the radius, OC is the radius, and this will make this triangle to be an isosceles. Then angles opposite, we'll say the angles opposite equal sides. So if two sides are equal, then angles opposite to them are also equal. But where do we start? We start by finding this angle OCD. We know that if these lines are parallel, these two angles will be alternating. Then it means OCD is equals to 2x. Your reason will be alternating angles. OB is parallel to CD. Now, if this is 2x and we calculated x as 20, then it means that this angle here, it will be 40. Then this will be 40, and this will also be 40. Why is it 40? These are the angles opposite equal sides, because OD is the radius and then OC is the radius, and radii of the same circle are equal. Now, if this 2 is 40, 40, then OCD, it will be 180 minus 40 minus 40, then OCD will be 100 degrees. So it means here we're supposed to say we're calculating OCD. COD. We're supposed to calculate COD. Let's check quickly. We'll say COD. We're calculating this angle. So we can just say, let's put it. We'll say, this one will start here. After, okay. So let's put this. This was supposed to be a sub question. Let's put this one, then at the row where we put this angles. Let's go back. We'll go back here. But I think on the Google form, the question is there. Now, let's add the row. Then we remove this one because this was a separate question. It's a separate question. Now let's cut this one and paste it in the next row. Okay, cut, then paste. It means here it was supposed, this one was supposed to be a sub question, 2.2, where we are calculating COD. Then we say COD is, then this is how it was supposed to be. Now, you will follow the steps as I've explained. Now let's go to number 3. In the diagram below, O is the center of the circle, A is 38 degrees, and AD is the tangent to the circle at C. First question, find the size of O1. The size of O1 will be, first we'll say, in which triangle is the O1 that we are calculating? The O1 can be in triangle AOC or triangle BCO. But now, we are going to use the triangle that has a given magnitude. So we are going to use triangle AOC because we know angle A. And also we know that OC is perpendicular to AC, radius perpendicular to tangent. So it means C3 plus C4 is 90 degrees. Your reason will say radius perpendicular to tangent. So, and then it means O1 will be 180 degrees minus 90 degrees minus 38. Then that is where O1 will be 52 degrees. The second, the sub-question of number 3 will say, calculate the size of C4. Let's check where C4 is. C4 is here. Now, if you check, C4 is there. For C4, we can apply a tan-cot theorem. First, you'll say O1 is equals to 2E1. You can see that O1 equals to 2E1. Its angular center is twice the angle at the circumference. Then we say C4 equals to E1, tan-cot theorem. Number 4. In the diagram below, O is the center of the circle, A1 is 25 degrees, and E2 is equals to 20 degrees, and BC equals to ED. We are saying A1 is equals to 25, E2 is equals to 20, E2 equals to 20, and then BC equals to ED. BC equals to ED. First question, find the value of the size of A3. Now, we know that A1 is 25. So, and we know that here BC equals to DE. Now, A1 will be equals to A3 because equal chords subtend equal angles. So we're given that BC equals to ED. So if they are equal, remember this is a corollary of theorem number 4. So equal chords subtend equal angles on the circumference. So since A1 is 25, and then A3 is what we are calculating, and both the angle are subtended by equal chords. Therefore, A1 is equals to A3, then means A3 is also 25 degrees. Number 2, find the size of A2. Finding the size of A2, we know that O1 is equals to 2 times the whole of this angle. But now we're given E2 as 20 degrees. Now if you check, OE is the radius, OB is also a radius, then it makes triangle BOC to be an isosceles. So if it's an isosceles, the angles opposite equal sides are also equal. It means E2 equals to B2, they both equals to 20 degrees. Then if it's 20 is 20, then O1 will be 180 minus 20 minus 20, then O1 will be 140. But now we know that the angular center is twice the angle at the circumference. So O1 is 140 and A1 alone is 25, and then A3 is also 25. They make 50. But remember, the angle at center is twice the angle at the circumference. And then it means that the angle at the circumference must be 70 because it's half of O1. So since A1 and A3, they're both 25. So and then the whole angle must be 70. Then A2 would be 20 degrees. So A2 would be 20 degrees. Okay, we go to number 5. In the diagram below, circle with center O, quadrilateral AOBC, two tangents are drawn from the same point. First question, which of the following is correct about quadrilateral A? Which one is incorrect? So in other words, we want the incorrect one. Is B, is the quadrilateral acyclic? The answer is yes. It's yes because radius perpendicular to tangent, this angle is 90. Radius perpendicular to tangent, this is 90. And we know that if two opposite angles of any quadrilateral are supplementary, then that quadrilateral is acyclic. It means this is a cyclic quad, then your reason will say converse opposite angles of a cyclic quad. It means we want the incorrect answer. Then A, we say it is cyclic quad. Then the answer is correct. Then it is incorrect. Meaning, remember, we don't want the correct answer. We want the incorrect one. So the first statement which says it is a quadrilateral, yes, it is a quadrilateral, is a correct statement, which is incorrect answer because we want the incorrect answer. B or C is they're similar. Yes, they're congruent. Yes, they're congruent because we have side condition. We have side condition. If you check, we talk about the two triangle AOC and BOC. AO equals to OB, read I. AC is equals to CB, two tangents drawn from the same point. Then OC is common. So this make these two triangles to be congruent. They meet the side condition. Then this will be a cyclic quadrilateral. It means number 2 is not the correct answer because it's correct. We want the incorrect answer. Now, OB is the tangent to the circle passing through B, C, and D. Now, we say OB is a tangent to the circle passing through we said OC, OB is the circle, is the tangent to circle passing through B, C, and D. Let's check whether the statement is true. Now, we have proven that this is a cyclic quad. If it's a cyclic quad, this A2 will be equals to C2. But from congruency, C2 equals to C1. If C2 equals to C1, remember, if the two triangles are congruent, angles opposite to equal sides are also equal. AO equals to OB. AO is opposite to C2, OB is opposite to C1. Therefore, C1 and C2 are equal from congruency. If they are equal, then therefore B2 is equals to C1. Now, is this the third statement correct? Yes. OB is a tangent to the circle passing through B, C, and D. So, is it the correct answer? It is incorrect because we want the incorrect answer, and this is correct. So here we applied the converse of tan chord theorem. D, quadrilateral is a square. Is it a square? there's nothing that we can point out to justify that this is a square. Yes, two opposites are equal. It looks like a kite more than to be a square. So there's no condition that, remember, for something to be, all sides must be equal. So there's no reason for us to say AO equals to AC. So in this case, it means the incorrect answer is D, which is the correct answer. The correct one is C, which is the correct answer in this case. So the correct answer is D, because this is not a square. Now, number 6, in the diagram, BCED is a parallelogram. The ratio of AB is to BD is 4:3. Then BC is 20 centimeter. Remember, here there are no arrows, but we know that if we are told that this is a parallelogram, opposites are parallel. In other words, BC is parallel to DE and also DF, because DEF are collinear. So they are parallel, and also CE is parallel to AD. The first question, FE is to DE. We want the ratio here. FE is to DE. FE is to DE is what? First we'll say we were given the ratio of AB is to BD. So AB is to BD is equals to AC is to CF. Prop theorem, because BC is parallel to DF. Now, what are we required to calculate? Remember, the ratio of AB to BD is 4:3. So AC is to CF is also 4:3. But now in this case, we want EF is to DE. Remember, if this is 4:3, it means when you say FE is to DE, it will be 3:4, because EF is corresponding to CF, and then DE is corresponding to AC. Now we use the prop theorem, now with CE being parallel to AD. 6.2, the length of EF is, let's look at EF. EF, now we'll say, remember we've shown that EF is to ED is 3:4, and then ED we know it because opposite sides of a parallelogram are equal. Means DE is also 20 centimeter. So if D is 20 centimeter, then you'll say EF is to DE. We'll say EF is to DE is 3:4. So then you say FE over 20 is equals to 3/4. Then you cross multiply, then FE would be 15 centimeter. Number 7, you are given, in the diagram below, you are given a parallelogram again. We have shown all the lines which are parallel have been shown. AC is parallel to FG, then AF is parallel to CG, and then BD is parallel to AG. The length of ED is, let's check where ED is. Remember, we know that the FG is equals to 24 units. FE equals to 24 units. FG, let's check. FG is equals to 24 units. So if FG is 24 units, it means AC is also 24 units. So then we say AB is to AC is equals to ED is to CE, which is 1/3, but FE is equals to CE. Remember, the diagonals of a parallelogram bisect each other. FE is equals to EC. But first we said we are given that AB is to BC. AB is to AC is 1:3. So, and then it means, but we know that AB over AC is equals to ED over CE. And CE equals to FE because the diagonals of a parallelogram bisect each other. Now we'll have 1/3. Now it means where we see CE, you will put 18, then you cross multiply, then ED will be the third of 18, which is 6 units. Now, the next one, we say the area. We want the ratio of the area of BCF is to area of, let's copy and paste and work looking into the diagram. Before we come back to this part, let's copy and paste and see what we're calculating here. Now, I'll just copy this here and then take it to the diagram so that we calculate what we see. Now, we want the ratio of the area of BCF is to the area of CFG. Now, let's look at BCF. BCF is this one. And then CFG. CFG is this one. Now, since we know that AC is parallel to FG, whenever the lines are parallel, the length of the height between those parallel lines is equal everywhere. So that is why now if you check in this one, we said AC is 24 units, AB is third of 24, which is 8. Now we say the area of BCF is half BC times H. Then the area of CFG is half FG times H. Why do we say H? H is the same because when the lines are parallel, the height between the parallel lines is always having the same length. Then this will cancel, they cancel. We'll say the area will be BC over FG, then that will be 16 over 24, which is 2:3. Therefore, the ratio of area of triangle BCF and the area of triangle CFG is 2:3. Number 8. You are given the two triangles with the small touch, the larger one internally, and then these two circles have a common tangent. The first question, is quadrilateral AEFC parallelogram, trapezium, kite, or none of the above? Let's check whether is one of them or none. Okay, let's look at this. If you check here, H3 equals to A2, Tancourt theorem. The very same H3 equals to E3 in the small circle, Tancourt theorem again. Now, if they both equals to H3, it means A2 equals to E3, because they're both equals to H3. Now, if A2 equals to E3, therefore AC is parallel to EF. The reason is that the corresponding angles are equal. So then it means that quadrilateral is a trapezium. It's a trapezium because only one pair of the sides are parallel. Otherwise, if both pairs were parallel, we'll say it's a parallelogram, but it's not in this case because only one pair of the sides are parallel. Now AH times CF is what? We look at this, we have just proven that AC is parallel to EF. So when you say AH is to CF, AH is to CF, AH is to CF equals to. So since we have proven that the lines are parallel, you will say AH over AE. We say AH over AE. Let's just start here. We say AH over AE. AH over AE equals to CH over CF. Prop theorem, because the two lines are parallel. Now you can see that we say prop theorem because the two lines are parallel. And then which lines are parallel in this case? We know that AC is parallel to EF. We know that AC, prop theorem, because AC is parallel to CF. Then you apply the prop theorem. Then when you cross multiply, then it means AH over CF will be CH times AE. Now it's further given that EH equals to. Now we found the first one in 8.2 using prop theorem. Now we come again and say AH over EH is equals to AC over EF. AH over EH, AH over EH is equals to AH over EH is equals to CH over FH. It will be CH over FH. But now, when you look into this one, here we check, we have the sides like AC and EF. So in this case, you'll first show that the lines are, you know that if one of the sides is the parallel lines, you can't apply prop theorem, you will apply similarity. By mere looking, you see that the two triangles, this triangle EFH and triangle ACH, they are similar because E3 equals to A2 corresponding, F1 is equals to C2 corresponding, and then EH2 is the common angle. If it's a common angle, then we'll say therefore the two triangles are similar. Let's write them in the order that I'm talking. I'll just highlight here. I'll show you. Let's just quickly go back and show you how this is done. Remember, when you show similarity, you must put them in that order how they're equal. So then you will say, let's make it smaller so that we have space, and then you'll say triangle E. You say triangle EFH is similar to triangle ACH. That's the angle. So if they are equal, now we'll put them in that order. Remember, E equals to A, F equals to C, and then H equals to H. You put them in this order so that your proportion will be correct. Then let's go back there. Now, remember, you are required to prove EH over EF. So first you look at this similarity here. Let's show this. The two triangles are similar as I've shown. Then we'll say AH equals to AH, which is this one, over EH. AH is first and the last, EH is the first and the last. So equals to AC. AC is the first two, EF the first two. Then when you make AH the subject of the formula, then you cross multiply, then it will be EH times AC over EF. Now, then you go back to number 2. Then in number 2, where there's AH, you put EH times AC over EF. That's here. Then you go back here, then you substitute. You get back here, which is this one. Then you substitute AH by the answer you got here. CF is still this one, CH is still this one, A is still this one. Then you say, because now we want EH over EF, then you will take this 2 to the denominator this side. Then EH over EF will be CH is equals to CH times AE divided by AC times CF. Last one I wanted to test the converse of similarity. Remember, if two triangles are similar, whose hypotenuses are proportional, then the converse is, if two triangles are proportional, then they are similar. So in this case, we're given the fractions. Let's see if they are proportional. In triangle ABG and triangle CFD. Now, we check the longest side in this triangle and the longest side in this triangle. Here the longest side is 16 centimeter, and then the longest side here is 12 centimeter. 16 over 12 is 4 over 3. Then you divide the second longest. Here is 12 and 9. 12 divided by 9 is also 4 over 3. 8 divided by 6 is also 4 over 3. It means because when you divide the sides, you get the same answer. You say the two triangles are proportional. If the two triangles are proportional, then those triangles are similar. And if they are similar, angles to the opposite to the sides that you divided together, they are also equal. So it means because we divided AC by FD, it means now, remember AG is opposite to angle B, then FD is opposite to C, then it means angle B equals to angle C. Now the question is, the two triangles on the given options are similar. Which order is correct? Remember, when you show similarity, you must show them the way they're equal. But remember, the equal angles are the ones opposite to the sides that we divided together. Let's start with the first one. If you check, we divided BG by CD. BG is opposite to A. CD is opposite to C. Therefore, A equals to C. Therefore, A equals to, remember we said BG, BG is opposite to A, and then CD is opposite to F. So therefore, A equals to F. That's why we started with A here. Here we started with F. Now, let's check other ones that we divided. So again, we divided AG by FD. AG is opposite to B, then FD is opposite to C. That is why the B equals to C. Then the last ones we divided AB by CF. Remember, AB is opposite to G, that is CF is opposite to D. That's why G equals to D. So in similarity and congruency, you must arrange them in that order, the way the angles are equal to each other. But don't forget that the equal angles are the angles opposite to the sides that you divided together to determine your proportion. Thank you so much for watching. I just hope that you find this mediation useful. Keep on watching, and then until you grasp some of the things that you were not confident with. Thank you.